Right now, you are moving faster than a jet aircraft. You just cannot feel it. The planet beneath your feet is spinning at incredible speed. At the equator, Earth rotates at about 1,670 kilometers per hour. Even where you stand, you are traveling eastward at hundreds of kilometers per hour. The ground, the air, the oceans, your body, everything is moving together, so it feels perfectly still. But imagine this. Without warning, without slowing down, Earth stops spinning. Instantly, for 1 second, the crust beneath you freezes in place. The rock stops. The ground stops. But you do not. The air does not. The oceans do not. Because inertia does not disappear just because the planet does. The moment rotation halts, everything not fused to bedrock continues moving eastward at its original speed. At the equator, that means over 1,600 kilometers per hour of sideways motion. The atmosphere becomes a global shockwave. Winds stronger than any hurricane ever recorded tear across continents. Skyscrapers shear from their foundations. Bridges snap under sideways force. Entire cities are shredded by debris moving faster than sound. Aircraft in flight are hurled violently as the air mass keeps racing forward. Vehicles slide uncontrollably. Anything not deeply anchored is ripped away in an instant. But the oceans carry even greater momentum. Millions of tons of water surge eastward, refusing to stop. Coastlines vanish beneath walls of water, moving at unimaginable speed. Entire regions are swallowed within seconds. And Earth is not a perfect sphere. Its rotation creates an equatorial bulge, pushing mass outward through centrifugal force. When rotation suddenly stops, that outward force disappears. Gravity immediately begins pulling water and land back toward a more spherical shape. The crust experiences sudden stress. Fault lines strain under redistributed pressure. The planet groans under forces it was never meant to feel so abruptly. Then, after exactly 1 second, rotation resumes. The crust begins spinning again into an atmosphere and ocean already displaced. The returning motion collides with chaos. Secondary shock waves ripple across continents. Dust, water, debris, and fire fill the sky. All of this unfolds in a single second. And the destruction does not end when motion returns. Because momentum accumulated over billions of years does not vanish quietly. It releases energy. And that energy reshapes the surface of the planet in ways humanity has never witnessed. That reshaping does not stop with shattered buildings or flooded coastlines. It continues beneath the surface, inside the oceans, and deep within the planet itself. The violence of that single frozen second forces Earth to redistribute mass instantly, and physics does not forgive sudden imbalance. The oceans, still carrying enormous momentum, surge eastward even after rotation resumes. Coastlines that survived the initial shock now face secondary waves as displaced water searches for equilibrium. Ports vanish. Low-lying cities disappear beneath chaotic flooding. Entire regions are altered permanently. But the oceans are only part of the story. Earth's rotation creates an equatorial bulge, a slight widening of the planet caused by centrifugal force. When that force vanished for 1 second, gravity immediately began pulling water and crust toward the poles. That rapid redistribution of mass introduces tectonic stress across fault lines worldwide. Earthquakes erupt across continents. Volcanic systems destabilize. Pressure builds and releases unpredictably. The crust was never designed to handle an instantaneous halt in angular momentum, and the atmosphere remains unstable. Jet streams rely on rotational dynamics to maintain structure. Interrupt them, and wind systems lose coherence. Storm patterns form where none should exist. Temperature gradients shift violently. Even though the planet resumes spinning, the atmosphere does not instantly return to balance. But perhaps the most underestimated consequence lies deeper. Beneath the crust, Earth's liquid outer core spins and circulates, generating the magnetic field that shields the planet from solar radiation. A sudden halt in surface rotation could introduce turbulence between crust and core, disrupting the delicate balance of the geodynamo. Even a temporary weakening of the magnetic field would expose satellites and power grids to intensified solar particles. Communication networks falter. Electrical systems surge. The consequences cascade outward. All of this from a single second, because 1 second may feel small to you, but planetary physics does not scale to human intuition. Angular momentum built over billions of years does not stop gently. It resists, and when it is forced to pause, even briefly, the release of imbalance spreads through every layer of the planet. After the chaos settles, survivors would attempt to understand what happened. Scientists would analyze data. Satellites would reconstruct motion, anomalies. Seismographs would record the impossible pause. And a deeper realization would emerge. Earth's rotation is not just background motion. It defines day and night. It shapes climate zones. It governs wind systems and ocean currents. It stabilizes life's rhythm. For 1 second, humanity would learn how fragile that stability truly is. But consider something even more unsettling. If Earth can stop for 1 second and resume, what mechanism allowed that? No known force within our current understanding of physics could halt planetary angular momentum instantly without unimaginable energy exchange. To stop Earth rotation requires energy comparable to billions of nuclear explosions. The fact that it could happen without the planet shattering implies forces beyond conventional physics. And that thought lingers. Because if something can interrupt a planetary constant so effortlessly, then rotation itself is not sacred. It is conditional. Over geological time, Earth's rotation has been gradually slowing due to tidal friction from Moon. Days grow longer by milliseconds per century. That change is slow, predictable, measurable. But compressing change into 1 second transforms gentle evolution into violent shock. The event reveals something deeper about existence. Stability is not guaranteed. It is sustained. The spin of the planet feels eternal only because it has never visibly failed within human memory. But that does not make it immune. After the disaster, life would continue. Cities would rebuild. Systems would adapt. But psychologically, humanity would carry a new awareness. The planet is not a fixed stage. It is a dynamic machine of motion and balance. And the real question is not what would happen if Earth stopped spinning for 1 second. The real question is this: how many invisible forces are keeping your world stable right now? And if one of them paused, even briefly, would you survive the moment when everything you trusted stopped moving?